Okay, so we're going to talk a little bit more about infection in general now, because understanding how infection works and how it's transmitted helps us be able to prevent that transmission and protect patients. First, the chain of infection, we have the causative agent. So that's whatever microorganism causes the infection. It could be bacteria, virus, fungus, whatever microorganism that is. Prions are not considered microorganisms, but they do carry infectious disease. They're bits of genetic material. A reservoir, you have to have a reservoir. So we have the bug. Where is the bug? Okay, the reservoir can be a human, an animal, food, contaminated surfaces, water, soil, insects. So what we're looking at is where that bug is until it gets transmitted to the next victim, the next infected person. So humans are the only reservoir for some organisms. So if we have an organism and humans are the only reservoir, then contact is going to be how that's passed, from contact from one person to another. There are organisms that animals can be a reservoir. So like rabies. If an animal with rabies, if their saliva, if a person comes in contact with their saliva, then they can become infected. So there are insect-borne illnesses. So think the reservoir is where that bug is now. Okay. The portal of exit is how does it leave the host? So it's in that host, in the reservoir, how does it get out? Because that's going to affect what we need to do to prevent getting it or prevent transmission to others. It can be through the respiratory tract, through the GI tract, through the genitourinary tract, through skin and mucous membranes, through blood and body fluids, through the placenta. And this is going to be specific to organisms. The mode of transmission. And now this is going to depend partly on that portal of exit. So contact, infections that are passed on by contact are going to be things that are passed on in feces or in respiratory secretions or by the skin. Okay, so think about some things that you know can be passed on that way. These are infections that require direct physical contact or indirect contact from object to person. Fecal oral is also considered contact because most organisms pass by fecal oral route, can remain on surfaces. Someone touches that surface or shakes hands with a person who has that on their hands and then transfers it to their mouth. So those are things that are transmitted by contact. Droplet is if something is transferred by aerosolized droplets in the air. And these are larger particles. So they maybe go about 3 feet. This would be sneezing, coughing, talking, that we're spraying microscopic particles of saliva. What's in that? What's in those respiratory secretions? Or what's in those droplets of saliva. So think about things like flu, most colds, RSV, those are transmitted a lot by droplets. Now, there are some diseases that are transmitted by both droplet and contact because those droplets land on a surface. If they can live on that surface long enough for someone else to touch it and pick it up, then that can be transmitted by both droplet and contact. Airborne, the organism travels in the air and it travels much further because it's a much smaller particle than just infected droplets. So think about things like TB and chickenpox, varicella. There's been some controversy since COVID began over whether it is droplet or airborne. And it's fairly well established now that it's airborne. So it also can be transmitted by droplets, I believe, but it's pretty clear now that it's an airborne infection. That's why they're recommending N95s now. So the organism itself travels in the air with airborne. So sneezing, coughing, talking, laughing, anything that makes air go further is going to increase transmission. Vector-borne, an animal or insect is an intermediate host and transfers that infection to a human. So think about tick-borne illnesses or mosquito-borne illnesses. So that's the mode of transmission. Now, what's the portal of entry is how the host gets it. So this is how the new host gets this infection. This may be the same as the portal of exit, but it may not be. The eyes are an under-recognized portal of entry for a lot of respiratory viruses, for example. Someone with a respiratory virus of some sort coughs or talks, and that virus is in the air in droplets. If the eye may be a portal of entry, even if the rest of that person's mucous membranes are protected. So think about where that gets into the new person. And then there has to be a susceptible host. And whether the host is susceptible, whether they actually get the infection, it's going to depend on two things. So when you've been exposed to an organism, whether you get the infection depends on how virulent that organism is, how likely it is to infect. So there are some bugs that are going to infect everybody they touch, and there are some bugs that don't infect as many people that are not immunosuppressed. And the other thing is what kind of defense mechanisms that person have. So I want you to make sure that you understand the chain of infection. Okay, we have a causative agent, we have a reservoir, which is the current host. We have a portal of exit. How does it get out of the current host? We have a mode of transmission, which is going to be really closely connected to that portal of exit. We have a portal of entry. How does it get into the new host? And we have a new host that is susceptible. That's the chain of infection. So to prevent infection, we need to break that chain somewhere. You also need to know the stages of infection, because that's really important in establishing infection prevention precautions. So incubation is the time between the entrance of the pathogen to the onset of symptoms. Some bugs have a really short incubation. You're exposed one day, you're sick by the next day or within hours. Some bugs may incubate for 2 weeks before you have symptoms. So what is the incubation period? Prodromal is when you're beginning to have some general symptoms, but there aren't really specific symptoms yet. The pathogen is multiplying. So the prodrome can be vague and you're not really sure if you're getting sick. And if you are, you don't really know with what, okay? Illness is when you have symptoms specific to the infection. Convalescence is when acute symptoms disappear. Complete recovery can take days to months. So I want to apply this for a second to COVID. The incubation period of COVID is anywhere from 2 to 14 days, or that was the initial incubation period. There may actually be differences with the newer variants, but initially 2 to 14 days, okay? But COVID also had a really long prodrome. So after someone develops that infection, they then might have really mild symptoms for 5 to 7 days. That's the prodromal period. Their symptoms are mild, they're not real specific. Am I having allergies? Is it a cold? Am I just tired? And then the illness period, when someone became acutely ill with COVID, recognizable COVID symptoms, was further down that time frame. What that meant for transmission is that a lot of people had been exposed. They also learned early on that you're contagious for about 2 days before you begin to have symptoms. So you have about 2 days of transmission before you start to have symptoms. And then you have another probably week of really mild symptoms where people were still going about their business, going to church, going to school, going to work, shopping, all of those things. So that's a really long stretch of time to pass that virus. And that's one of the things that made this virus really much more effective in terms of infecting a population than previous SARS type viruses. that long prodrome. So the illness period is when you have symptoms specific to that infection, and then convalescence is when you're getting better, and that can take days to weeks to months. Okay, that is the general how infection works, and then we're going to talk about risk factors in the next video.